Assalamualaikum warahmatullahi wabarakatuh and good day. Today our group will present about Bernoulli theory. So for the abstract, the purpose of this experiment is to demonstrate how to compute the total pressure head, static pressure head and dynamic pressure head change over time using Bernoulli theorem. The setup includes a venturimeter, tube manometer, a water tank with a pump, water bath and tubing, among other components. In this experiment, a venturimeter is used to measure fluid flow via a tank. Next, for the background, a practical application of Bernoulli principle is the venturi tube. The venturi tube has an inlet that narrows to a throat at concentric point and an outlet section that increases in diameter towards the rear. The diameter of the outlet is the same as that of the inlet. So the mass of air entering the tube must exactly equal the mass exiting the tube. Next, for the problem statements, there are variation of total pressure head, static static head and dynamic head that required to investigate. The measurement of total pressure is by the pitted tube measurement on the right side of the apparatus. So static head is measured through the multi-tube manometer at the top portion of the apparatus. Next, for the objective, we have three objectives, which are to determine total pressure head, static head, and dynamic head of the fluid flow through volumetric tank. Last but not least, for the scope, to investigate the variation of total pressure head, static head, and dynamic head. Second, to measure the static head through the multi-tube manometer at the top portion of the apparatus. Third, to calculate the velocity of fluid through volumetric tank of and from the dynamic head. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is BMM3521, MBA 1823. So my part is chapter 2 and chapter 3. So let's start. This is chapter 2, where is theory. 1. Theory of Bernoulli's principle. Number 1 is the test. This experiment is to test and validate Bernoulli's principle in fluid flow. Second, an increase in fluid speed occurs simultaneously with a decrease in static pressure or a decrease in fluid's potential energy. Third is only applies to isentropic flows with irreversible process such as turbulent and non-adiabatic process. Is the derivation of Bernoulli's principle. Number 1. To maintain a constant volume flow rate, incompressible fluid must accelerate when they enter a narrow constrict section. Next, the work energy principle exemplifies this, where W external equals to total K over 1 over 2 mv to F minus 1 over 2 mv to I. Last, if a portion of fluid accelerates, something outside of that portion of fluid is doing work on it. 2.3. Bernoulli theorem. Number 1, the pressure energy, kinetic energy, and potential energy are all continuous add up in the streamline. The formula is pressure head plus velocity head plus elevation equals to constant. So the last part of the theory is 2.4, realistic assumptions of Bernoulli's principle. Number 1, no energy is lost due to dissipative force. And number 2, there's a figure of water flowing along streamline from left to right. Okay, let's jump to chapter 3, which is method and procedure. So this is the apparatus needed in the experiment 3.1. The following equipment is required for this experiment: pellet tube, venturi tube, manometer, motor pump, water tank, stopwatch, pipe valve, single metameter valve, manometer valve, water flow control valve. So this is the apparatus setup for Bernoulli's principle experiment. So the following is the procedure of the experiment. Number 1, and the first step is the pipe valve, manometer valve, and water control valve must all be properly installed according to the diagram, and each component must be checked to be completely open, while valve H2 is half open. Number 2, the motor pump is started by increasing the flow rate of the water by adjusting the water flow valve and the overflowing of water in the manometer valve and pilot manometer valve remove any air bubbles from both manometer. The single plated manometer valve and manometer valve are then to be closed. The pump is to be turned off and pipe valve H2 is to be closed while pipe valve H1 remain open. Step number 4, to allow airflow into the system. Open the manometer valve and the single plated manometer valve. The plated and manometer valve are closed when half of the columns are crossed. Then reopen and pipe valve H2 is fully open. Step number 6, set the water flow control valve from tubing H1 to tubing H6 to ensure that all the water level in the manometer could be read. Plated head and static head measurement were taken in the venturi tube. The flow rate was recorded based on the volume of water, and the stopwatch was used to monitor and record the rise of the water tank. That's the last step. That's all from me. Thank you.
Thank you, Muhammad Faiz. So I will explain about the result of this experiment. First is table 1. Table 1 show internal diameter, radius, and area of each point. We take the example 4.1. Inner diameter, which is 28.4 millimeter, and divide by 2 to get the radius 14.20 millimeter. And we also can calculate the area by using the formula pi r square divided by 1000 square. The answer is 6.335 times 10 power of -4 meter square. Table 2 show a static head, pitot head, total head, measured and calculated dynamic head. Head dynamic measure we can calculate by using the head pitot minus head static. 250 minus 240, 10 millimeter. Head dynamic calculated using the formula velocity squared divided by 2g. G is gravitational acceleration. 0.4154 squared divided by 2 times 8.91. The answer is 8.7952 millimeter. Head total calculated by using the formula head static plus head dynamic calculated. 240 plus 8.7952, we get 248.7952 millimeter. Table 3 show a velocity measured and velocity calculated. Velocity measured square root 2g head dynamic divided by 1000 to get the meter per second. 2 times 9.81 times 10 divided by 1000 square root 0.4429 meter per second. In order to get the velocity calculated by using the formula volume flow rate divided by area, 2.27 times 10 to power negative 4 divided by 6.335 times 10 to power negative 4. The velocity calculated is 0.4154 meter per second. Pressure dynamic measure rho, which is the density of the water, times the gravitational acceleration times the head dynamic measure. Rho is 1000 times 9.01, which is the gravitational acceleration, times 0.01 head dynamic measure. The pressure dynamic measure is 68.10 kilopascal. Pressure dynamic calculated also using the same formula, rho GH, and the answer is 66.28 kilopascal. Figure 1 show a graph of total head and head dynamic against point. We have 6 points, and the higher the head, which is at a point 3, around 150. The second figure show a graph of measured and calculated velocity against point. We also can see that point 3 have a higher velocity. It means that the higher the total head, the higher the velocity. Figure 3, graph of measured and calculated pressure dynamic versus point. We also can see that point 3 have achieved a higher pressure. It means that the higher the head, the higher the velocity, and also the higher pressure. Next, I will pass to Alif Luqman to continue the presentation.
Thank you, Amirul. Now I will continue our presentation with the discussion. The purpose of this experiment is to prove the Bernoulli's equation and also the variation when applied to steady flow water in tapered tube. As we know, one of the characteristics of fluid that they are able to take on the geometry of the tube. Since the amount of fluid flowing through a given length of pipe is constant over the given period of time, the pressure is decreasing. And here we can see the equation of Bernoulli's principle. And this equation relates the friction, velocity, and height of any 2 points in a steady streamline flowing fluid, such as point 1 and point 2. And this equation applies to the energy conservation theorem, which is applicable to moving fluid. And according to Bernoulli's theorem, as the velocity increase, the pressure also increase. And from this experiment, the result and graph obtained has satisfied the Bernoulli's principle. When the diameter of tube is decreased, the flow rate will also decrease and resulting the increase in flow velocity. And this increasing of flow velocity will then decrease the static head and increase the dynamic head. And there is a slight difference between measured and calculated velocity. This is because in real situation, there are losses in pipes due to friction. Furthermore, there are also other factors that differentiate the measured and calculated velocities, such as parallax error, systemic error, and also random error. And that's all for our discussion. Next, we will proceed with conclusion presented by Azmel. Thank you.
Thank you, Alif Luqman. And now I will continue to present about the conclusion. As a conclusion, we have successfully done this experiment virtually based on a given video and collected data. We also have determined the total pressure head of the fluid flow through the volumetric tank. This experiment also has demonstrated the Bernoulli's theorem of the energy efficiency in the streamline. After that, we have determined the static head and dynamic head of the fluid flow through the volumetric tank by using the formula of the head dynamic, pressure head, pressure dynamic, velocity, and head total. And lastly, as a result, loss in pipes due to pipe friction reduces the accuracy of the reading. Also, the measurement speed is different from the calculation speed due to the parallax error, environmental error, systematic error, and random errors. That's all from us. Thank you.